Okay, so this is on the Graphing Linear Equations foldable. So when you open up the first flap, it says parts of a graph. So we have the x-axis is the horizontal axis. The vertical one is called the y-axis. And then the point 0, 0 is called the origin. So it is the point 0, 0. Where the graph goes through the x-axis, that's called the x-intercept. And where the graph goes through the y-axis, that's called the y-intercept. And those are the main features of a graph. All right, on your foldable, let's go ahead and look at the tab that says vertical and horizontal lines. So go ahead and open your foldable up to that position. All right, so a horizontal line is when we have it as y equals some number. That's a horizontal line. It goes through the point 0, that number. So this, for example, would be y equals 3. And notice it goes through the point 0, 3. Okay, the slope is 0. The x-intercept, it does not go through the x-axis, so there is none. And the y-intercept is at 0, 3. Or a general form would be 0, b. b is just the number that y equals. Okay, on a vertical line, the slope is undefined. So any vertical line has an undefined slope. So the graph x equals a, so it has an x-intercept at a0. It has no y-intercept. So in this case, if you look here, 1, 2, 3, 4, this is at x equals negative 4. So this is a vertical line because it's x equals negative 4. And so this x-intercept would be negative 4, 0. So whatever the number is, x equals whatever number is where the x-intercept is at. It's that number, comma, 0. All right, so let's do a little practice here on our foldable. So it says graph y equals 4. Well, if it's y equals the number, you know that it is a horizontal line. And so it's going to go through 4 and be horizontal. So that's the graph of y equals 4. So the graph of x equals negative 2 is going to be vertical. Anytime it's x equals a number, it's a vertical line. And it's going through negative 2. So you're going to draw a vertical line through negative 2. Remember, this one has a slope that is undefined. All right, now it wants us to write the equation of the line shown in the graph below. Okay, so in the graph below, this is a horizontal line, and a horizontal line is y equals the number. And it goes through negative 5, so it's y equals negative 5. This over here is a vertical line, so it's x equals when it's vertical, and it goes through 3, so it's x equals 3. Okay, so now let's go ahead and practice looking at how to graph a linear equation in standard form. Okay, so when it's in standard form, you're going to find the x-intercept and then the y-intercept, and you plot both those points on the graph, and then just draw the line through those 2 points. So let's look over here. So the left side here shows you how to find them algebraically. So there's 2 methods here. To find the x-intercept, you substitute 0 in for y. So we would have 2x minus 4, but put a 0 in where y is. That's what it says right here. Substitute 0 in for y. So now solve for x. Well, negative 4 times 0 is 0. So basically it goes away, and you have 2x equals 16. Divide by 2. We get x equals 8. So when we plug 0 in for y, we get 8 for x. So that's one of our intercepts. So now to find the y-intercept, substitute 0 in for x. So just switch it, substitute 0 in for x, and solve for y. So 2 times 0 is 0. So it essentially disappears. You get negative 4y equals 16. Divide by negative 4, and you get negative 16 divided by negative 4 is negative 4. So 0, negative 4 is your y-intercept. All right, so then on a graph, essentially what you do here is you'd have x equals 8. I'm going to go by 2's here, 2, 4, 6, 8. So x equals 8, 0, and y equals negative 4. I'm going to go by 2's here. So you put your 2 points on there, and then you just draw a straight line going through them. Okay, so this is the cover-up method. Basically, you can just cover up the y instead of substituting in 0. The reason it works is because if you're plugging in 0, it's going to disappear. So you can essentially just cover up the y. So this is called the cover-up method. So it says to find the x-intercept, cover up 7y. So essentially, you put your finger over the 7y, and what you're left with is 3x equals negative 21. You can see right here, I've just kind of crossed it out. So you have 3x equals negative 21. Now solve for x. You get negative 7. So the x-intercept is negative 7, 0. Okay, so the y-intercept, to find y, cover up x. So cover up the 3x. You're left with 7y equals 21. Equals negative 21. Divide by 7, and you get negative 3. So the y-intercept's at negative 3. So if you think about this on a graph, if I just sketch a quick graph, the x-intercept's at negative 7. That's right here. The y-intercept's at negative 3. And then you would just draw a line going through those 2 points. And that would be your graph. Okay, let's look at some notes here. We're not going to do all of them because we've done a lot of practice here, but let's do some quick examples. So I'm going to have you graph the equation on example 1a of y equals 4. Okay, so y equals 4 would be a horizontal line because y equals is horizontal, going through 4, 1, 2, 3, 4, and all the way across. Always extend it all the way across. That would be the graph of y equals 4. Okay, now I'm going to have you graph example 1b. What is the graph of x equals negative 2? Okay, so it would be a vertical line going through negative 2. And make sure to extend all the way through. So when we have x equals a number, it's a vertical line, and we just draw it on going through the x-axis where the number is. All right, let's look at example 2. So what would the x-intercept be on example 2a? All right, so to find the x-intercept on example 2a, if you look at your foldable, you have 2 options. You can do it algebraically or you can do a cover-up method. So to find the x-intercept, you would cover up the y. So you'd have 3x equals 12. Divide by 3, and you'd get 4. So that'd be 4, 0. All right, I'm going to go ahead and plot that point. Okay, and go ahead and find the y-intercept. What is the y-intercept on example 2a? All right, so to find the y-intercept, you'd cover up the x or put in 0 for x. Find the y. The y is 3, so that'd be 0, 3. So you'd go ahead and graph those, and then you would just draw a line going through them. It works a lot better with just using a straight edge, but in this case, it's a little tricky to get it on this board, but that is about where it would be right there. Okay. So let's go ahead and see what else we've got going on here. Let's do this word problem. Exploration 1. You sold a total of $16 worth of tickets to a fundraiser. Okay, so that's the total amount of tickets you sold. You lost track of how many of each type you sold. Adult tickets are $4, child tickets are $2. So X is the number of adult tickets. Okay, so where it says number of adult tickets, I'm putting an X. Let Y represent the number of child tickets. That's Y. And we want to fill in the numbers. So the price per adult was $4 per adult. So that is 4x. The price per child was $2. So that's plus 2y. And the total amount of tickets you sold was $16. So 4x plus 2y equals 16. All right, let's go ahead and do a table of how many tickets you may have sold. All right, so we plug in a 0 for x, and if we did that, we just plug in 0 for x, and we would find out that y equals 8. Okay, so if we tried plugging in a 1 for x, so if you sold 1 adult ticket, it'd be 4 times 1 plus 2y equals 16. Subtract the 4. You get 2y equals 12. Divide by 2, so y equals 6. So you could sell 1 adult ticket and 6 child tickets. Okay, what if you sold 2 adult tickets? 4 times 2 plus 2y equals 16. All right, I'm going to solve for y now. Subtract the 8, divide by 2. If I sell 2 adult tickets, I can do 4 child tickets. Okay, if I do 3, then I'm going to do the same thing. I'm just going to go on scratch paper and I'm going to find out that I can do 2 child tickets. And if I sell 4 adult tickets, then I can't buy any child tickets. All right, so let's go ahead and plot the points from the table. So X is adult. And I don't have room down there, so I'm just going to write adult out to the side. The number of adult tickets. I should probably be clear in my label here. And then adults, I can do 0, 1, 2, 3, or 4. So I think I could just go by ones. All right, and then this is the number of child tickets. And I just need to go up to 8, so I think I have room to go by ones again. 5, 6, 7, 8. All right, so if you do 0 adult tickets, you can do 8 child. We put a dot there. 1 adult ticket is 6 child. Put a dot. 2 adult tickets is 4 children tickets. 3 adult tickets is 2 children tickets. And 4 adult and no kids. Okay, we don't connect them because you can't buy like 1.5 adult tickets, so it's a discrete function, so we do not connect the points. All right, let's go ahead and try one more example. You're planning an awards banquet for your school. You need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 6 people, large tables seat 10 people. So that's where the 6 and the 10 and the 180 come from. X is the number of small tables, and Y is the number of large tables. All right, so it wants us to graph the equation. So I'm going to make a table here. So I'm going to try it first. If I buy 0 small tables, X is small, Y is large. Okay, so what I'm essentially doing is I'm plugging in 0 for X and I'm solving for Y. So I'm not going to show every single step here, but essentially I'm just plugging 0 in for X and solving for Y, and I get 18. Okay, so then if I plug in 1 for X, so 6 times 1 plus 10Y. So if I do that, then I'm going to get like 17.4 for Y. Well, you can't buy 17.4 large tables. So like I don't think that is really working for us. So I'm not going to choose to use that point. Essentially, I'm only going to choose to use points that work with whole numbers because you can't buy a partial table. That's not going to work. Okay, so what I'm going to do is just give you some points here that do work out. And let's see here. So when I plug in 5 for small tables, I get 15 large. That works out nice and whole. When I plug in 10, I get 12 large. 15 small is 9 large. 20 is 6. So 20 small, 6 large. 25 and 3. And 30 small and 0 large. Those are all my options. So it wants us to graph the equations and interpret the intercepts. So first, let's interpret the intercepts. So the intercepts are right here, 0, 18, and 30, 0. So what 0, 18 means is it means if you buy 0 or rent 0 small tables, then you can rent 18 large tables. Okay, what 30, 0 means is if you rent 30 small tables, then you can rent 0 large tables. Okay, so here's the graph that it would look like. I plotted the points on the graph. X is the small tables, Y is the large tables. So now it says find 4 possible solutions in the context of the problem. Any numbers that are whole integers from your table could be solutions. So you can choose any 4 of those to be possible solutions in the problem.